Welcome to today's class. Today we are going to cover the charging current in transmission line. This case study, we have a line-to-line voltage for the three-phase voltage is 220 kilovolt, and the face-to-face clearance is 6 meter. This is actually the symmetrical spacing for this system. So 6 meter each, and of course A to C will be 12 meter. And the conductor here, let's consider for this case study the length for the conductor or the cables, say 80 kilometer, as well as the frequency for the system, let's say 50 hertz. Okay, to calculate the charging current, we have to have the capacitance for the system. Okay, before that, what is our line to line voltage? So line to line voltage is 220 kilovolt, which is given in the question. So face to face voltage will be 220 over root 3. So we'll get 127 kilovolt. And D equivalent, the symmetrical or equilateral spacing, D equivalent is equals to cubic root, and of course the distance will be 3, so DAB, DBC, and DAC. Let's plug in this value inside the cubic root. So this is 3 6 2 times, because DAB and DBC are equal 6 each, so 6 square, and this will be 12. Finally, the D equivalent is equals to, we found 7.56 meter, and the conductor diameter R is equals to 1.81 centimeter. Let's convert this into meter. Indeed, 1.81 into 10 to the power minus 2 meter. Now it's time to calculate the capacitance, because we have to have the capacitance to calculate the charge current, right, or charging current for the transmission line. So the capacitance, let's write down the capacitance per phase per kilometer. So C is equals to 2 pi epsilon naught over ln D equivalent over the radius of the conductor. Here epsilon naught is the permeability, which is refer the medium where the cables belongs to. So let's plug in all this value. So this will be 2 pi. The value of epsilon will be 8.85 into 10 to the power minus 12 over ln. So D equivalent value is 7.56 over, this is 1.81 into 10 to the power minus 2. So the final value will be 9.2 into 10 to the power minus 3 microfarad per phase per kilometer. Now it's time to calculate the total line capacitance. The total line capacitance, which is C is equals to, let's write down here a subscript Cn times the length, which is 80 kilometer we have considered. So this value will be 9.2 into 10 to the power minus 3 and 80 kilometer. Okay, so the final result will be 0.736 microfarad per phase. Now it's time to recall the final equation to calculate the total line charging current. So the total line charging current, line charging current. So the equation for line charging current is equals to 2 pi f times the line capacitance, the total line capacitance, and the phase voltage. So let's plug in all this value. 2 pi, value of f is 50, the value of C, the total line capacitance, is 0.736, and this is micro, that's why we have to write down. Okay, let's 10 to the power minus 6, and the phase voltage is 1 to 7, as the final value will be in ampere. So let's write down here as it is 127 kilovolt. So let's write down here 10 to the power 3 volt. So the final result will be 2937 ampere per phase. This is the final answer for the case study.